Recent advances in IoT technology are causing a huge amount of data being generated in real time. Such data arise in several application domains, including healthcare monitoring, smart building, smart grid, and etc. These data are typically collected from sensors, and we can view them as streaming time series. It's challenging to process the streaming time series. As a huge amount of data arrive in real time, we cannot store and process the data offline. Also, the processing speed has to be very fast, as the data is generated at a very high rate. Moreover, the processing may involve complex computations. A natural approach to developing such an application is to write the algorithm in a general-purpose programming language, such as C. But this requires programmers to figure out what exact state to maintain, how to update the state for each input item, and how to produce the output. So I argue that this is cumbersome and error-prone, and this does not facilitate the modular description of complex computation. Therefore, a lot of specialized languages, compilers, and runtime systems are proposed to deal with this issue. Depending on the application, each approach has its own strength. For the application we are interested in, the language needs to integrate various streaming constructs to describe the computation. So we designed StreamQL that has a rich set of streaming constructs. The key design choice of StreamQL is that it identifies an appropriate programming abstraction. That is, we base the language on the abstraction of stream transformations. The basic elements of StreamQL are stream transformations, like filter, map, and streaming aggregation, and its combinators are operations on stream transformations, like window and pipeline. Based on this abstraction, StreamQL allows all its streaming constructs to be composed freely, and it has a formal denotational semantics. Finally, this abstraction enables a very lightweight implementation that avoids the construction of intermediate streams. We have implemented StreamQL as a Java library and compared it with three popular libraries, RxJava, Reactor, and CD. We have tested the performance of StreamQL in 4 benchmarks. These benchmarks include a micro benchmark concerning basic streaming computations and other 3 benchmarks related with realistic workloads. Here we summarize the throughput speedup of StreamQL compared with other libraries. The results show that StreamQL has a competitive performance.